Hi, my name is Sam McSweeney. I'm a researcher at Curtin University. At Curtin University, the Pulsar and Fast Transients team are conducting an all-sky pulsar survey called the Southern Sky Murchison Wide Field Array Rapid 2-Meter Pulsar Survey, or the SMART survey for short. This survey tiles the sky with 70 MWA pointings, with each pointing having a dwell time of about 18 minutes. Earlier this year, we published the first new pulsar to be discovered in our so-called shallow pass, where we perform a full periodicity search in just the first 10 minutes of data from each pointing. More recently, we discovered the bright pulsar, which I'm showing on the screen now. Actually, in this instance, it turned out that the Green Bank telescope beat us to the punch with a 2018 detection. But despite that, this pulsar is precisely the kind of pulsar to which the SMART survey is designed to be sensitive. The reason is that this pulsar is an intermittent pulsar, with its burst activity occasionally switching off and staying off, what we call nulling, for tens of minutes at a time. So actually, we got lucky when we detected it in our initial search of 10 minutes of data. But we know it has long nulling periods by virtue of other archival MWA observations in which we found it during follow-up. So if we were able to detect this pulsar, there is a good chance that there are a lot of other intermittent nulling pulsars out there waiting to be discovered with the SMART survey. The coolest thing about this pulsar, however, is its single pulse activity. Firstly, it is what we call a subpulse drifter, which means that successive pulses arrive at a slightly different time or rotation phase compared to the previous one. Moreover, the size of this pulse-by-pulse shift, or the drift rate as we call it, can occasionally change suddenly, and we say that the pulsar exhibits multiple drift modes. Now, this pulsar not only has multiple drift modes, which is seen in several other pulsars with subpulse drifting, but even more curiously, the drift rate changes slowly and gradually throughout its drift modes, which is very rare. The reason this is interesting is because most theories about the drifting phenomenon, such as the celebrated carousel model, have as their starting point the notion that the drift rate should stay stable, which is certainly true for many pulsars with subpulse drifting. In other words, it is pulsars like this that have the potential to help us really drill down into what's driving the drifting phenomenon and thus shed light on the pulsar's emission mechanism. And we hope that this pulsar is representative of a whole population of pulsars which the full SMART survey, when complete, will be able to discover, pointing towards a bright future for low-frequency Southern Hemisphere pulsar studies. Thank you.